So let's take a look at how we can solve quadratic equations by what's called completing the square. And before we jump into how exactly we do that, there's two things that I want you to know and remember. One is the standard form of a quadratic equation, which if you remember is ax squared plus bx plus c, and what's called a perfect square binomial. This is kind of what we're trying to achieve using the completing the square method. And basically it's just a binomial in parentheses squared. Okay, and that's what we're trying to get to by the method that we're using here. So let's just jump right in. I can show you before we jump into how to actually solve these quadratic equations. Let me show you actually how we complete the square. So let's say we had some random quadratic like x squared plus 4x plus 6 equals, call it 15. So the whole goal with completing the square is to get your quadratic term and your linear term, your quadratic term and your linear term by themselves. Okay, I can't draw rectangles, so get them by themselves. So to do that, we would have to get rid of that positive 6. So let's go ahead and do that. Do that to both sides, and so our new equation is going to look like this. X squared plus 4x, and we're going to put a plus blank here. That's what it means to complete the square. We're going to put something right here. Equals, and on the right side we have 9. So to complete the square, all you do, and this is really pretty much it for completing the square itself, is you take the b value of the quadratic, and you're going to divide it by 2, so 4 divided by 2, and then you're going to square that. So 4 divided by 2 is 2, 2 squared is 4, and that's what we're going to put in right here. Now, this gets many people tripped up. We can't just add a 4 on the left side. We have to do the same thing to both sides. So we're going to add a 4 to the right side. You might miss one of those that everybody does eventually, but just remember, we can't just put a magic number on one side of the equation. Both sides have to equal out. So now we can actually, you can factor this using your normal technique. I still call it the AC method, or the AC method, but there's different types of methods for factoring quadratics. But with this one, the technique for if you have a perfect square trinomial, which this is just basically to take your b value and divide it by 2, take whatever your variable is, usually it's an x, but it could be something else, and we're going to go ahead and put them in a binomial. So x, in this case it's plus, and b divided by 2, that's just 2, and that's our binomial, and then we square that. That's this trinomial factored, okay? And so that technique I just showed you, that's how you complete the square. You just get rid of the c value, right? So this c value, we bring it over to the other side. And this right here, we take the b value, divide it by 2. Let me actually show you that without just saying it multiple times so you can actually see it. The value that's going to fit into this empty space right here is actually, change colors, b divided by 2 quantity squared, which seems like a lot, but once you do it multiple times, you'll get the hang of it pretty quickly. And once you've filled that value in, you have to put the same value on the other side, whether it's plus, which it actually will, it'll always be plus because we're squaring. So we put the same thing on both sides, and then once you've gotten to this point, now we can actually write our squared binomial, our perfect square binomial, by just taking whatever b is and dividing it by 2, that goes here, and whatever your variable is, that goes here, and that binomial will be squared. So with all that out of the way, hopefully that was not too quick, but it's a relatively straightforward process when you get the hang of it. Let's jump into a problem, and we actually want to solve this one. So like I said, we want to get our quadratic and our linear term by themselves, so we need to get rid of that 10. Okay, so let's rewrite that. We have x squared plus 4x plus blank, what we don't know yet, equals 10. So what goes here? Remember, b divided by 2 quantity squared. Now what is b from this quadratic? B is 4. So that's why I brought up that the standard form of a quadratic, the ax squared plus bx plus c, because you need to know, what is a, what is b, and what is c. So in this case, again, previous example I picked 4. This one's also 4, but so let's do that for this one. So 4 divided by 2, that's just 2. If we square that, we also get 4 again, so we'll add 4. But we have to do the same thing to both sides. And now we can go ahead and just jump into the basically the trick of going from our perfect square trinomial to a perfect square binomial. We know we're going to put our x here, and it's a plus, so x plus, and then right here I'm going to put b divided by 2, quantity squared. So what is b divided by 2? Well, it's 4 divided by 2, so we get a 2 there, equals 14. And so kind of like what we had last time, but we actually want to solve these. We wouldn't just leave it like this because we actually want to solve for the variable. But that's why this is so important and why it's so useful, is because we know how to solve this and get rid of that square. We square root, and we do that to both sides. And so now this would cancel on the other side, or on the left side. Cancel out that quadratic. We get x plus 2 equals. Now remember, when you square root something squared, you get a plus and a minus. So I'm going to have a plus and a minus over here. And then we're close. We don't care about what x plus 2 is. We want x by itself. So let's get rid of that. Subtract 2, subtract 2. So we get, and I'm just going to get rid of it here, x equals plus or minus square root of 14 minus 2. So one of your answers would be positive root 14 minus 2. One of your answers would be negative root 14 minus 2, but you can use that plus or minus notation. It's kind of convenient. And so that's pretty much it. It's really just remembering that b divided by 2 quantity squared. That's what goes in this blank spot that I put there. And then adding that to both sides. And that part gets a lot of people, but there's one thing that I left off, and this technique only works if your a value, so the coefficient on your quadratic term, is 1. And we're going to have, I think the next example, or the example after that, is going to be one where it's not. And it's pretty straightforward how to get it to a 1. You just divide, but keep that in mind. That also trips people up. This has to be a 1. If it's not, if it was a 2, we'd have to get rid of that. Okay, and we will do one of those in a bit. Let's try another one. So similar idea. We want to get our quadratic and linear term by themselves. So basically we want to get rid of the c value. That's probably an easier way to say what I've been saying this whole time. So let's get rid of that c value. So subtract off 15 minus 15. And let's rewrite this. We get x squared plus 6x plus something we don't know yet equals minus 5. So what goes in here? Well, what is our b value divided by 2 all squared? So 6 divided by 2, that's 3 squared. So we get a 9 here. And so we just added a random 9, so we have to add a 9 to the right side as well to keep the equations, the sides in balance. And now we can get to work on the left side. So this is just, the right side is just 4, the left side. So what do we get? We can use that new, the new, I keep calling it trick, the trick, I guess if you want to call it that. We have our variable here. There's a plus. And then what goes in here is just b divided by 2. Some people, kind of put this whole b divided by 2 squared in there, but once you get practice, you'll get the hang of it pretty quickly. And if you're ever not sure of your answer, just factor it out. So b divided by 2, that's 6 divided by 2, that's just a 3, quantity squared. And when I say factor it out, it's like, oh, well, that's a lot of work, but you can check your answer really quick. If I squared this, just so you can see it, x plus 3, yikes, x times x squared, x times 3 plus 3 times x, so there's a 6x plus 3 times 3, so we get our 9. So that works out. We know that that's our correct binomial squared. Okay, and now we do what we did last time. We're trying to solve for x, so hopefully you can kind of see, like, all right, well, how do we get x by itself? The first thing we have to do is get rid of that squared term, so let's square root that. Square root, and so that cancels it on the left side, and we're just left with whatever's underneath the radical, equals, again, because we square rooted something squared, we get a plus or minus, and then square root of 4, that's just a nice 2. And so we're close. Let's subtract that 3, subtract 3. And with this one, the previous problem that we had, if you remember, we had a radical, so this would be okay to leave it like this. But with this one, because we have nice whole numbers, depending on your teacher, they might want you to simplify that out. So it would be, if it was positive 2 minus 3, that would be minus 1. If it was negative 2 minus 3, that'd be minus 5. So they might want you to actually write, negative 1 or, negative 5. Okay. Again, you might be able to get away with that, but generally, if it's a whole number, sometimes the teacher will take off if you don't fully simplify that. And that's it for that one. So let's try one where the quadratic coefficient is not 1. Let's see how we do that. Let me zoom out a bit. All right. So there's a couple techniques for this one. I find this one to be easier, even if it leads to fractions, which sometimes it will. We haven't done one of this where we have fractions. They do come up. But basically, we do the same idea. Let's get rid of our c value, so we're just left with our quadratic and our linear term. So let's get rid of that 9. Get 18 equals our 3x squared plus 6x plus blank. So if you remember, we can't actually. I guess before I put the blank, let's bring this back together. So again, I wouldn't say the number one rule, but one of the most important rules is we can't do the completing the square technique if our quadratic has a coefficient that's not 1. So let's get rid of that. The easiest way to do that is just divide by 3. Divide everything by 3. And so we can rewrite our equation. And now we can do, because this has a 1, let's put our plus blank. We're going to fill that in. Equals 6. See what we get. So what do we put here? If you remember, we've got our b divided by 2. I'm going to keep writing this so you see it a lot, so you don't forget it. In this case, b is just 2, so 2 divided by 2 is 1. 1 squared is still 1. So we added a 1, so we need to add 1 over here. And then what would this simplify to? So we know we've completed our square, so that's going to factor into a perfect square binomial. So we know it's going to be a binomial. Put our variable here. You notice they've all been x. Been really unique on those. But so we x plus, and then b divided by 2 here. Just the no square, just the b divided by 2. In that case, it's 2 divided by 2. So just 1. Quantity squared. And if we factor this back out, FOIL this back out, we get x times x squared, plus x times 1, plus 1 times x, so that's a 2x, plus 1 times 1, which is a 1, so that's correct. And then equals 7. Okay, we're close. Remember, we want to solve these, so you don't want to, you might leave it like this on a, homework, whatever. It happens all the time, but remember, when we're solving these, our goal is we want to figure out what x is. So don't leave it like that. So first thing, okay, we can get rid of, try green, we can get rid of this squared by square rooting. We do the same thing to both sides. It cancels out the square on the left side, and we're just left with that nice x plus 1 equals, again, plus or minus. If you square root something squared, you get a plus minus. I missed that a lot in class growing up, so I'm going to make a big point of emphasizing that. And we're close, really close. We just need to get rid of that 1. Minus 1, minus 1. And because this is just, let me bring this down a bit. Because this is just we have a radical there, this would be one where you could just leave it like that. There wouldn't be any simplifying unless they said, round your answer to the nearest decimal place. This would be the precise answer, the exact answer. Okay, so plus or minus root 7, minus 1. And that's pretty much it. So the only real unique ones that you have that we haven't really hit are ones where if we had to do what we just did up here, you had to divide by 3. Like you might end up with a fraction, okay? And like if you have let's say we ended up with 2/5, this could happen. 2/5 was our b value, and you have to do this. That's not very fun, So make sure you practice your fractions, because let's say that was b in a random quadratic that we're doing, completing the square on. Well, 2/5 divided by 2, that's 2/10, or 1/5 if I simplified it, which I probably should. And then if we square that, I am going to simplify that. 1/5, 1 over 5. If we square that, we get 1/25, right? So that would be what goes in here. So not very fun, but again, everything still works in terms of, okay, well, what goes here? It's b divided by 2 squared. What goes after we've got that value? How do we go from here to our binomial? Same exact thing, take your variable, and then take whatever b divided by 2 is. In this random example I just gave you, it would be 1/5. So x plus 1/5 squared. That's perfectly fine. Again, nobody likes doing these with fractions, but they probably will come up at some point. But this video is running a little bit longer, excuse me, so I apologize. But hopefully, we kind of gave you an example of how we use completing the square to solve quadratic equations. And I wanted to go through just a few ones. I didn't get to do one where we ended up with a negative that we square root. But if you're comfortable, let's say we had, just for example, and I'm going to go off a tangent here. Let's say we completed a square and we ended up with, x plus 2, yikes, squared equals, -5. Well, same exact thing. Everything's exactly the same. We would just square root both sides. Notice we're taking the square root of a negative. Right, so everything's the same. X plus 2 equals. Now, when we're square rooting a -5, you can't leave it like that because we can't take the square root of a -5, right? We need to pull out that negative. If you remember, that's going to be an I. Okay. So and you'll see it written like this pretty much by everybody. Put the I in front of the square root. It's just generally the kind of the standard for that. And then we still have our plus minus, and then we subtract the 2 in this case. So -2. So it looks just like the other one that we had with square roots, but if it's a negative, you're just going to have an I in front of that square root. Okay. And that's pretty much it for these. Again, like I said, with the fractions, you might come across some stuff. You might end up on the right side. When you square root, you might end up with something like, square root of 72. And that's going to be on you to notice, oh, I can simplify that radical to, root 36 times root 2. Root 36 is 6. Right? So you miss little points for not doing stuff like that. And really, it depends on the teacher, but pretty much every teacher would kind of mark off if you left it like that. They want you to simplify as much as possible. Anyway, hopefully this helped a little bit. Leave your comments below if you think I missed anything, if you'd like to see anything else kind of related to this. Hopefully it helped, and I'll see you in the next one.